Problem 4 is about defining sets using exhaustive enumeration and some of the challenges that provides. So in this example, 3, 5, ... there's some ambiguity. What's the rule there? Is it all the odd prime numbers? Is it the odds? There are several that it could be. So there are a couple ways to think about that. Maybe what's held there is 3, 5, 7, 9, 11, 13, all the odds. If that's the case, then what that's describing is all x in z greater than 2, we'll say, such that x mod 2 is equal to 1. So it's all the odds, all the odd numbers greater than 2. So that's a possibility. All sorts. So the simple ones will also say 3, 5, 7, 11, 13, 17, onward, where this is the primes. So we're going to say x in, and we'll say just z greater than 2. There's several ways you could write out this abstract notation. It could be all the primes that are odd, but I'll just say greater than 2, and that fixes it for me, such that x is prime. So it's the odd primes. The first one was the odd numbers. Okay. Here's another one that we could think of. We could say 3, 5, 8, 13, 21, 34. And hopefully we can see what that is. These are the Fibonacci numbers. So you could write this as x in z greater than 2, such that x is a Fibonacci number. And I would accept that. And the Fibonacci numbers are those numbers. So typically we start from Fibonacci 0 equals 0, Fibonacci 1 equals 1, and for all I greater than 1, fi equals fi minus 1 plus fi minus 2. It's the sum of the last two numbers. And so you can see that 8 is 3 plus 5. 13 is 5 plus 8, and so on and so forth. So you just keep adding the two numbers beforehand. That's another one. And there are several ways that you could more formally write this out, but I just care that you capture that it's a Fibonacci number if that's your answer. And there are many more creative possibilities for what this could imply. So I'm trying to think of, let's see, 8 minus 3. So you could think of 3 as 4 minus 1, and 5 as 8 minus 2 minus 1. So the next number in that set could be 16 minus 3 minus 2 minus 1. And the next number could be times 2, so 32 minus 4 minus 2 minus 1. Keep going. And if you see that pattern, 2 to the k minus the sum I equals 1 to k minus 1, such that k is in z greater than 1. So from 2 upward. And there's an odd one. There's an unusual one. But the list goes on. There's no limit to this. And as long as your set abstraction works, it's all good.